Hey, what's up, y'all? Originally when I started doing this FVD Elements series and the Let's Play FVD and NoLimits 2, my goal was to produce specific elements for people who had already scoured the internet looking at FVD videos and knew a little bit about the program. But I assumed that everyone who was looking at my designs had probably already seen most of those and had some basic knowledge of FVD. But what I've discovered over the past year is that quite a few people who are watching actually haven't worked with the program at all, but are interested in trying it out. So rather than tell them, oh, go look at this video or go consult that source, I figured why not just do my own basics in an easy to follow format, and that should help some of those folks out. So what you're going to find is this video is divided into a few basic sections explaining how the various forces and track sections that we work with in FVD are done, as well as some tips and a quick build of a coaster. Each section will be marked at the bottom left of the screen. As you see here, it says introduction. That marking will stay there for the entire duration of that section. That will help you out if in the future you remember that I said something when we were talking about, say, lateral forces, but you don't want to have to watch the whole video. You could just sort of scroll back and forth to find that particular section. And then you can also always refer back to my first build of something wicked. Episodes 1, 2, and 3, I believe, maybe 4 even, we did the entire coaster from start to finish. They're very long videos, but they're also very thorough, so those should be very helpful. But with all that said, it's time to get started, so let's roll. Alright, so FVD stands for Force Vector Design. This is not something that just trips naturally off your tongue, most likely, but I can give you a simple definition. What that means is, rather than manipulating track sections by dragging them where we want them to go, we manipulate them using graphs so that we specify the forces that will be felt on the rider's body as they travel over those sections. It sounds complicated, but don't worry, you'll get the hang of it, and I'm here to help. Alright, so when you first open the program, you are met with a blank screen. There are a few things you might want to do before you get going. The first being go to Edit and Options, and you'll get a pop-up window where you can choose the measurements that you want to use. I'm using imperial units, but you have the option to choose metric as well. Once you've got that set, hit OK, and you can also go to Help and Conversions, where you'll get another pop-up window which shows you all the various heart lines that are appropriate for whichever type of coaster that you want to build. There are also other tools I've seen in forums and so forth that give more exacting heart lines, but I think these work pretty well. So next we can go to Properties, and this is where you specify friction parameters as well as your heart line and what type of track that you want to use. I usually use a friction parameter of 0.027. I know that that's not 100% accurate, but it works out well enough. For now, we're going to keep the heart line at 1.10, and for track style, we'll say, let's just go with B&M. And you can also choose to uncheck wireframe right here, and what that will do is show actual track instead of just a wireframe track. So click OK, and then we are ready to go to Edit. So the next thing that pops up, we're getting closer to actually starting on our track, but first we have our anchor right here. This is our anchor point, which functions like the start vertex in NoLimits 2. So really you don't have to do too much with this. By default, I think it's at 3 meters or 12.795 feet. I usually just leave it there unless I specifically want it to be higher. Actually, for B&M, I'll probably go a little bit higher. I'll just change this to 22 feet. And that's all I pretty much have to do right now. So what we're ready to do next is start talking about sections. So we're going to go to Add, and we see 4 types of sections here: straight, curved, force, and geometric. So of the 4 sections, we're going to start with a straight section, and that is exactly what it says. It's a straight section of track. What you'll see here is the fixed speed is 22.369 miles per hour, and the length of the heart line is 32 feet. Let's go ahead and make a station. So we'll say the fixed speed is about 8 miles an hour, and we'll say it's 75 feet long. So there we go. We have a straight section of track. Next is the curve section, and that's exactly what it sounds like. It's a curved section of track. This fixed speed is always right here. Again, we're going to make that 8 miles an hour. The radius is the radius of the curve. The total angle is 90 degrees. That's obvious. The direction is 90. When it's 90 degrees, it's going 90 degrees to the left. If you make it negative 90, it's going 90 degrees to the right. If you make it 0, it is going uphill. And if you make it negative 180, it is going downhill. So basically you just made a little drop right there, a 90-degree drop. But that's not typically how we do it in FVD, and what we're doing right now is just creating the track to the lift. So we're going to make it 0 degrees direction, and the total angle will make 30 degrees. So that conforms just about to a normal lift hill angle. Then of course you have the force section, which we will work with momentarily. Let's go ahead and add a straight section so that we can start on this drop. We'll make it 8 miles an hour again, and we will do the length of the hard line at about, let's say, 100 feet and see where that takes us. All right, so you see right here, this Y value right here denotes the height that we're at right now. So that means we're at 83 feet roughly. Let's go ahead and make this, just take it up to 100. So if we keep extending the length of this hard line, we'll see we get to about 95 degrees. So there is one other type of section that we can add, which is geometric, or force and geometric. For now, we're not going to deal with geometric sections. They're a little bit more complicated than force sections, and I just want to focus on force sections. So I'm going to add one more curve section at the top to make the rollover at the top of the hill. Let's say this is a pretty small B&M, actually, now that I think about it, but we'll say it is 8 miles an hour. The total angle is 45 degrees, and the direction is negative 180. We want it going down so that it is facing towards the ground. And finally, the lead in and lead out, what that does is creates a smooth change from the straight section to the turning section right up here. Instead of just having it be going straight and then bam into a turn, the 10 degrees causes it to be just a little bit smoother. So what I typically do though is when I'm creating this rollover at the top of the hill, for the lead out, I'm going to put 0 because we're going to put a force section there in just a minute. So those are the 3 main sections. Now we're going to add the force section, which is really what FVD is all about. By default, sections are 1 second long. In the graph pane, you can scroll by clicking and holding, or you can shrink and expand the size of the graph by rolling your mouse wheel. There are 3 graphs we work with when we're working with the force sections. Those are normal force, lateral force, and roll. Right now we're going to create a drop with no lateral forces or rolling, so we'll check the box beside dynamic on the lateral and the roll graphs. What this does is make those graphs automatically match the length of the normal force graph. Keep in mind the track will only appear up to the point where all 3 sections of the graph have been created. In other words, if you make a long section of normal force but haven't extended the lateral or roll graphs, no graph will appear. So normal force is the normal force of gravity. It's 1g, what you're feeling right now. In other words, if you're just sitting and watching this video, unless you're on the moon or you happen to be riding a coaster or something like that, you're feeling 1g right now. Coaster forces can range from extremes from -2 very briefly to 6Gs very briefly, but those are the extremes. I tend to go from about -1 to an average of say 3.5 with spikes up to 4Gs or so. There are tables of values that have been worked out that show how long you can maintain a rider at certain forces. If I can find those, I will link them in the description. So for each force section, there are different types of graphs that we can choose. If you're just starting out in FVD, you're going to stick with cubic or quartic. Cubic allows you to set the change and leave it at that level, and quartic allows you to just do a quick change and then back to normal. Doesn't make sense right now, but we'll see how that works in just a minute. So for our drop, I'm going to do a cubic function. I'm going to click on the normal force and let's just roll this down to about where we want it to. So let's say you can see right here under vertical acceleration that we're now at about 0 Gs, which seems reasonable for a B&M. The shape is a little bit off, so what I'm going to do is just extend this a little bit so it starts to look a little bit more like what a B&M would look like. We're going to then click append to add another 1 second length of graph, and we're going to bring this up to about 3.5 Gs. And again, Keep an eye on the vertical acceleration over here as we go up to 3.5 Gs. 2.5, so we'll say right there is fine. I'm going to extend the time just a little bit, and then we're going to append one more time. So you see what happens here. We used a cubic function. So what this does is once the change happens, it stays at this level. So that leaves constant 3.5 Gs right here. I'm going to just, because this is just touching the ground, let's see, this is 1.2. I'm going to make this section of the graph down to the 0G just 1/10 of a second shorter. And there we go, we've got a drop. It's not 100% perfect. It doesn't look exactly like what a B&M would look like, but that's okay. We're just doing something really fast here. So now we've got 1 second of positive Gs. We're going to extend this one more time with append. And you see, because it's still set at positive G, the track bends to keep it at that level. Instead, we're going to take this down to just a negative one more time. So let's get down to about 0 and append one more time. So obviously this looks like nothing we want. So what happens often in FVD is you have to consider what came before this piece of track you're working on. So what came before was this long section of positive Gs. If we just reduce this just a little bit, we get more of the shape up here. And I'm going to go ahead and turn off, if we click graph list and editable graphs, we can uncheck lateral forces, because you see it disappears from right there. If I check it again, it reappears. We're not dealing with lats right now. We've got it set on dynamic, so it just stays dynamic. So I'm just unchecking it so it disappears. We've got 1 G, or we've got 0 Gs here floating up, and we're holding it right there for 1 second. So we've got 1 second of 0 Gs. And by the way, if you want to take a ride on this coaster to see what it looks like, just right click anywhere in this pane and hit the space bar, and you will go up the lift hill. You can use W and S to move forwards and backwards, and you can use shift to go faster or slower. So let's just go down the hill real fast and see what this looks like. All right, for something that we did fairly quickly, came out pretty good. So now let's move on to roll. Okay, to do that, we're just going to make a quick turn right here. So I'm going to continue the negative G section for just a moment. You see it's extending here. We're holding it at negative Gs for 1.3 seconds. And then we are going to append to take this back up to positive Gs. The reason we're doing this is because we want sort of a downward helix right here. Let me just move over a little bit. We want sort of a downward helix right here. And in order to do that, we need both roll in the track, but we also need positive Gs, so that, of course, anytime you've ridden a helix, you experience positive G-force sections. So this entire time we've had the roll right here dynamic. We're going to uncheck that, and we're just going to reduce the seconds back a little bit so that we can start the roll about right there. So we hit append, make this just a little bit longer, about 1.2 seconds, and then I'm going to type in a preliminary value of, say, 90 degrees. So if we actually ride this for a second, you'll see that the roll has been introduced. It's a little bit rough right now and jarring, but that's all right. We'll fix that. Let me just extend this portion. Again, remember what I said, that you often have to change what came before if you want to change this. And what I want to change this is make the roll start just a little bit later, or make this be in a more, the pitch, which is the upwards or downward direction, to be going more downward. So I'm just going to extend this just a little bit. And then I will extend this portion right here before the roll kicks in just a little bit as well. There we go. So then I'm going to append on both the normal force and the roll. I'm going to append a section. And what that does is just help us see how what we do right here is going to play out on this roll right here. So I'm going to make this a little bit longer. Let's make it 1.5 seconds. And I'm going to roll it just a little bit more so that it continues down. And if we ride that, we'll see that it's a little bit rough, but it's all right. We're just doing something really quick right here. So our goal was to do a downward helix. We've done that. You see that we did not do that by specifying the banking at any point. You can see the roll right here is plus 21 degrees. As we go through here, if you watch that, you see the banking change. but at no point did we specify what the banking was going to be. We just specified what the roll value was. But that means everywhere on this graph says what amount of roll is happening at that given time. So the roll is going all the way up to 136 degrees, and then it starts coming back down, and it remains steady. So this entire time it's rolling, 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 and then it's coming back down, and now it's remaining steady. So if we extend this indefinitely, we'll go ahead and click, let's click roll one more time and make it dynamic. And then we'll extend the normal force just for a certain distance, and the roll never changes now. It's always steady. It's going to remain right where it was. So your first question will be, well, now if I want it to go straight, how do I get it back to what it should be? And that's what I'm going to show you. That's something that people generally have trouble with. So the easiest way to do that is just to roll back. So if we take this section right here, there are two ways to do this. Using a quartic function, you can just scroll down to get it to roll back. And remember that both of these forces are acting on the track at the same time in this section. So it's going to remain at 3.5 Gs, or it's, what is it? Yeah, 3.5 Gs this entire time. So it's going to look a little bit weird at first. But let's just go ahead and take this down to negative 144, which should get it roughly accurate. And then this is a little bit too long. Let me uncheck dynamic on this. I'm gonna make this a little bit shorter so that we can again go up into a negative section. Make that one. We hit a pen. We're going to take it down just a little bit so that we can get an uphill sort of crest. A pen one more time. A pen to this. Now you see, obviously we've gone way too far. When we went back to 0, we went way too far. So let's make this shorter first of all. So about right there. And then that means, because we don't want it going off that direction, so we need this roll to last just a little bit longer. So I'm going to prepend a piece of track right there. And now you see that pointed it more in the direction that I wanted to go. So I'm just going to make this a little bit shorter, the straight section. And then I'm going to return to 0 by rolling this until the track up here in the roll section shows roughly 0. So you see it's getting closer and closer. So that's about accurate. That's good enough. I know people really want to be right at 0, but it really doesn't make a difference. And you see it's still a little bit rough. That's okay. It's probably because this is too short, actually. Generally for rolls, I never go below 1 second. And in fact, I like to do it even less than that. So let me just alter that a little, make this a little bit shorter so this is going back to where I want it. And I'm also going to change this normal force just a bit so that's not quite so high up. And there you see we're pretty much back to 0. So that's one way of doing it. Or you can continue roll if you want it all the way over, which I'm going to leave for just a second. Another way you can do it, though, if you download the version that I have and you click on tight, there is a return to 0 function. You can use that in the program will automatically calculate the track going exactly back to 0. You can see that right here. That works if you don't have too much roll to contend with. It's not good to rely on it all the time. It's best to roll back as close to 0 as you can get it, and then use it in the following segment. So let's undo what I just did. Actually turn this back to quartic. And I believe it was negative 124. Not 124, 0. That's roughly accurate. And then right here in this section, I'll make that return to 0. And so then you sort of get a kind of a side-to-side effect, which I kind of like sometimes. It's a little bit wonky, but we'll fix that in just a moment. So that's roll. Now we're going to do one last thing. We're going to put some lateral forces in here. And to do that, of course, we are going to manipulate the lateral graph, which you remember is the green graph here at the bottom. So I just click on that, and you see this was on dynamic the entire time, so it just followed along with everything we were doing before. So what I'm going to do is just put a little bit of lats right here on this turn right here. Now obviously B&M is not known for lats on their rides, but we're just fooling around here, so I want to show you that. So I'm going to uncheck dynamic, and we'll take it back just maybe to about right here. Man, no, let's take it about right there. And then append. We append, and I'm just going to make it longer so it goes out to the whole, or excuse me, it goes to the length of the whole entire track. And now let's go over here and take a look at this. And lats work, the lats graph, the lateral graph works just like the other graphs. You can use quartic or cubic. In this case, I'm going to use quartic. It's already set to quartic, and I'm probably just going to go down just a little bit. Let's see what it looks like. Lat's obviously changed the shape of the track, so that's something to keep in mind while you're working on that. So let's just take a look at this real fast. That's not what I wanted. Let's put negative and ride through here, and you'll see just a little bit of lats as we're going, and the lats are measured right over here. So that just kind of brings us back out to straight, and we're pretty much done. Let me put a little bit more lats in here so it matches up right there. So now we're pretty much straight. I'm going to go ahead and append on the end of this lat. I'm going to append on the end of the roll, and I'm going to append on the end of the normal force, and we pretty much then are headed right back to the station, which is what I wanted it to be. And that's all we're going to do for this this short little ride. But wait, you might be saying, you promised us you were going to smooth out this janky ride. So yes, that's what I'm going to do. The first thing I'm going to do is, after I finish this, remember that I just did this very quickly, so I'm going to just kind of refine this design as we go along. But the next thing I'm going to show you is smoothing over here. If you click smoothing, and there are all the pieces of the track that we did, starting with 0. 0 is the entire track, and then you can smooth each segment individually simply by clicking the enabled button beside which piece you want to smooth. I typically just smooth the entire track and then hit OK. I don't generally do each section differently, just because it really isn't needed if you do the design well. So if we take a quick ride on this, you'll see it still looks a little bit janky, but it already looks a little bit smoother. So if I refine the design just a little bit, it'll look better. And it already does look better overall. And you can see somewhat, if I zoom in here by scrolling the mouse wheel, you can see a dashed line here just barely underneath the red line that goes along here. And that's where the smoothing is taking place. So if you see that, it does a pretty decent job of just smoothing out anything you do. But mostly you want to make sure that the coaster that you design is smooth to begin with. So that's, once you've finished up your design, then you need to export it into NoLimits. To do that, you go to File and Export As. And this window will pop up, and you'll have the ability to choose whether you want to export to NoLimits X2 exporter, which is what you should go for. You choose the track that you want to export. In this case, we only have one track because we only created one track. If we go back to project, we could have separate tracks over here. We could add another track, and we could have multiple tracks. In this case, we just have the one. And then you export from section and to section. So we are going to go from 1 to section 5. Then you hit OK, and you choose the location where you want to export yours to. Click save, and now it's exported. So the very last thing that you need to do is import it into NoLimits 2. So now we're in NoLimits. The only two things you need to do before you import, you set up your new track, and under coaster properties, be sure under mode that you choose Heartline of current coaster. Then add your start vertex, and the one thing I like to do is select the start vertex and make sure the Y value is roughly the same height as the anchor point we chose in FVD. You'll recall that I did 22 feet. I'm going to add 3 feet to that just because the ground in NoLimits is about 1 meter, so we're going to make this about 25 feet. Hit enter. And then all you have to do with the start vertex selected, you can see it way down there in white. Just go to element, add element, and find where you saved the FVD element that you exported. Double click on it, hit OK, and there you go. Our element is imported into NoLimits 2. It is that easy. So now you're ready to do everything you normally do when you do a track. You can run a D-pump, put in the lift, put in all that sort of thing, and you're good to go. So that about summarizes everything that you can do in FVD, but before we go, I want to give you some tips. The first one is, for your first coaster, when you're first learning the program, don't try to do anything too wild. Just do a simple out and back coaster. Get the hang of working with the program, how it works, how you create positive and negative G's, how you do a few simple turns. Then you can move on to adding a new element or two in your next design. It takes a lot of practice to use FVD. I'm not going to lie to you, it's not something you're going to pick up and make the smiler, for example, the first time you try. So I know you have a lot of ideas for what you want to do, but just have a little patience too. Just give it some time. Some practical tips are play around with section lengths to see what results in the smoothest ride. Remember that the length of a transition should be longer or shorter depending on what speed the train is moving. So if you're transitioning from, say, 0 G's at the top of a hill, or going down a hill to 3.5 G's at the bottom of the hill, if the train is going 70 or 80 miles an hour, if that happens in a second, it's going to be very abrupt. So you might want to increase that length to maybe 1.2 seconds, 1.5 seconds, something like that. If you're working on something, say you're trying to make a turn or something, and it's not coming out the way you want it to, take a look at how you're approaching the entrance to that turn. Like I said before, whatever shape you're trying to create right now is very dependent on what came directly before it. So if it's not working out where you want it to be, just go back a step or two and try to alter something going into or out of that element to see if that helps it out. And then if you get close to an element, let's say you're trying to make a really complicated element. If you get close to an element that you like, but you still feel like it's close, but I could probably do better, save the file and then use the Add and From Other FVD project on the Project tab. This will allows you to import a copy of the file or the actual track, and you can keep that one and start working on the copy to make your tweaks. That way you can play around with the elements some more and still keep the original. So that's about it. If you have any questions or need something answered, feel free to leave a comment. I will include a link to the FVD file that we worked on in here, as well as a link to the force graphs I mentioned earlier, and the link to Something Wicked, the very first episode I did, which will show everything I built, a full-scale ride from start to finish, and explain the entire process along the way. Otherwise, congratulations, you're ready to take on FVD. Take care and enjoy the ride.